Well, good morning everyone. As you can tell from the slide in front of you, I've adopted a slightly different approach for this particular lecture. I've elected rather to give you guys a view of the slides and allow myself to sort of voice over the lecture. I think this may work out better for everyone involved because, of course, now that I'm not involved in the actual visual side of it, it's going to be a much more aesthetically appealing or better looking lecture because of it. But as you can tell from this opening slide, today we're going to be covering the science of problem solving, sometimes how we need to leap over logic. Now I've taken a quote from prominent neuroscientist Alan Shaw in this regard, who argues that too often we consider problem solving algorithmically, yet we forget that often problem solving is really about thinking inside the box. It's not just about leaps of logic, sometimes it's about leaping over logic. Now, considering that that's the case, and sort of linking back to our last lecture on language, I'd like you to consider the following. How do you tell when someone's lying? A problem, I suppose, that we're confronted with almost all of the time. When we consider how somebody is sort of able to act as a human lie detector, we often rely on true and tested strategies. Consider for a moment how you would tell. Would you perhaps look at meta-communicative cues, such as eye contact, voice tone, incongruities between the way that they speak and what they're saying? Would you perhaps look at content domains, how realistic their story is, how well it matches up to evidence, and how consistent they are? Would you look at physiological cues, such as how nervous they might be? All of these would sort of be in the normal algorithmic strategies for problem solving, sort of tried, true, and tested, but not necessarily the most efficient ways of finding out whether someone is lying. Those would be leaps of logic. However, intriguingly, neuroscience has offered us a new strategy, one that might in fact make use of a deficit we sometimes thought was just that. People with non-fluent aphasia have been shown in research to pick up on subtle intricacies and exaggerations of language and voice tone that those who are not aphasic, those who have normal neural processing of language, don't. People with non-fluent aphasia tend to find themselves laughing when they watch video footage or even live interactions where people are lying, largely because there are inflections of tone that they simply can't make sense of, which leads them to experience it as humorous or inconsistent and therefore somewhat confusing. In fact, so effective they have been is that they have actually been shown to be just as effective as polygraph tests on numerous controlled studies. Aphasia might in fact not only represent a loss of understanding, but it also could unlock new avenues of understanding, a leap over logic, so to speak. Different way of solving the same problem. If we're thinking back about what problem solving actually represents or how it operates, we need to consider the following. Problem solving may be defined in terms of a problem state. Now we argue that a problem state exists when a goal or desired state of being is being obstructed by an obstacle which we cannot immediately avoid or resolve. Problem solving therefore refers to our tendency or our process of trying to remove or deal with the obstruction in order to attain our desired state. Now, when we think of problem solving as it pertains to psychology, we can of course go to the dry cognitive theory, or we might in fact wish to look at one of the other applications, probably the most prominent application of our field, therapy. Consider for a moment this issue of why we need therapists to begin with, one that in the field we're confronted with a great deal. Someone might argue, why do I need to pay someone all this money to help me think through a problem I already know? Or if you follow some of the popular understandings about it, why do I need someone to help me solve a problem I don't understand in a way I can't comprehend? Well, if you think about it, there would be two strategies towards helping people with mental health. First would be to train specific people in order to become psychologists who may then of course assist them with these problems, which is a strategy we've adopted. But the alternative would be that if we could in fact act as our own therapists, wouldn't it make sense from a young age to just train everybody as psychologists? That way they could solve their own problems. Unfortunately, however, it doesn't seem to operate that way. Freud famously argued that no one is capable of analyzing themselves. So the question then becomes, why do we need somebody else to do it for us? Well, I'll explain in a moment, using what Gestalt psychologists have already taught us about problem solving. According to the Gestalt approach, which you'll likely remember from our chapter on perception, they argue that problem solving essentially involves two states. One, how a problem is represented in one's mind, so how we construct the problem. And second, how we can restructure the problem in order to solve it. Now, the way they sort of make this distinction is using insight versus non-insight problems. In insight problems, they argue that there is a sudden realization of the solution, so an aha moment, so to speak. And the example drawn upon in the textbook is one by Koller. He conducted an experiment in which he utilized a circle, which looks something like that. And he suggested that if that particular line running across in that triangle, the hypotenuse or the longest line, is x, he would like us to find the length of that line. Now, of course, one could go through all sorts of mathematical formulas and strategies to be able to find that. I don't mean to traumatize you by taking you back to metric geometry, but we could do that, the algorithmic way. But if you look carefully, there is a way, in fact, of finding that out with great ease. If you restructure the problem from that being a triangle with hypotenuse to that being a rectangle with one line going across diagonally, and therefore another line which would be of equal length going that way, we can immediately understand that x would be equal to the radius of the circle. X would equal r, and we could find the radius very, very easily. That would be restructuring the problem, re-representing it into your mind to be able to give yourself a simple but effective strategy for solution. Another example of this would be a fish tank problem, and this is a verbal one. Consider for the moment this problem. I have a fish tank that contains 10 fish. 2 die and 3 swim away. How many fish do I have left? Many of you may obviously recall this problem. We discussed it briefly before. But many of you may initially come up with the answer 5, some 7. But in truth, the answer is 10. How? Well, restructure the problem. We think that we lost 5 fish, 2 dying and 3 swimming away. But they're in a fish tank, meaning that they're all still in the fish tank and are still fish, even though they swam further away or passed away. Just by restructuring a problem in your mind, you might in fact be able to solve it quite easily and quickly. This is quite different from the process we use in non-insight problems, where we have sort of what they call a warmth or progress detection system. A system by which we can slowly but surely track our progress in solving a problem. And of course, a simple example of that would be algebra. You can slowly and progressively note that you're moving closer to a solution, or in fact further away, or feeling stunted. Now, when it comes back to this idea of therapy, we of course already understand therapy more often than not is an insight problem. We suddenly realize a solution through an interpretation or a reflection that in fact helps us to restructure the problem in our minds. This was in fact Freud's initial argument as to why we need psychotherapists. He argued that we're unable to act as our own therapists because we can only structure a problem in one way when it pertains to ourselves. We are blocked by different defenses, different understandings. However, when somebody else gives us an objective approach to it, when we have what he calls an interlocutor, somebody not prone to our same biases of thinking, they force us to restructure the problem in our mind and change the way we think about the problem in order to find a solution. We must realize, however, that problem solving also isn't by nature easy. If we go back to that definition, problem can only exist when there's an obstacle that we cannot immediately avoid or resolve. and therefore we are prone to certain errors which may serve as obstacles towards effective problem solving, the most common of which is being stuck in a mental set or a preconceived notion on how to approach a problem, thinking that there is only one way to skin a cat, so to speak. A very common manifestation of this is fixation, a tendency to focus only on certain aspects of the problem, to remain stuck on a few elements rather than a broader range of solutions. And of course, within fixation, the most common type of this is called functional fixedness, an excessive focus on one use of an object. And an excellent illustration of the broader concept of a mental set through functional fixedness is the two-string problem introduced by Meyer in 1931. In this experiment, participants were shown an image such as that within the bottom right-hand corner, in which there were two strings stationarily connected to the ceiling, a small table or chair with a set of pliers on it, and they essentially had to connect the two strings. However, once they held a string, they weren't allowed to let go of it. They had to be holding both strings at the same time. As you can immediately tell from the picture, all participants were immediately frustrated by the fact that they could not possibly reach the second string once they'd held the first one, even with the use of the table, which was the common next step. They would often stand on top of the table, hoping it would actually bridge the gap, but it didn't necessarily do so. Meyer found something interesting. Participants took several minutes, if not several hours, to try and actually solve the problem, unless they considered a different use for the pliers. Now, typically, of course, we think of pliers as a tool used to actually snip something or cut it open. But when participants began to recognize that the pliers could be tied to the second string and used as a pendulum to swing the string back and forth until the string immediately caught that person's hand, they solved the problem almost instantly. Meyer, when noticing participants were stuck in functional fixedness, would often walk past, brushing the string, illustrating the swinging movement which would lead participants to use the pliers as a pendulum. By recognizing an alternative, albeit unconventional use for the same object, participants solved the problem faster. They leapt over logic, which was extremely important. Fixation can take many forms, however, and one of the additional readings provided to you, that of Conan Smith 2010, shows how collaborative fixation, people brainstorming, may in fact lead to closing off ideas instead of generating solutions. It may lead to what Irving Janis famously termed groupthink, by forcing people to adopt the ideas of the most ardent or loud members. What's important to consider here is sometimes the obstacle to problem solving is our inability to consider alternative options. Now, while up until this point we focused almost exclusively on insight problems, of course, the argument is that there are also non-insight problems, things that we can progressively solve. And this is really what's been informing the information processing approach, or systematic solutions, to problem solving. Now, Newell and Simon, who you'll recall from Chapter 1, created the logic theorist program to mimic human decision-making, argued that there can be an algorithmic solution to any problem, a guaranteed process by which we can come to a solution. Now, if we use the simple everyday analogy of lost keys, I'm sure you'll all appreciate there's really two strategies you're left with. If one loses their keys, there we go, sorry, just refocusing. If one loses their keys, one could first attempt to find them by looking in the place where you likely last left them, and from there sort of backtrack all the possibilities. This would be sort of a more insight-oriented way of doing so, because of course there's an endemic strategy in terms of how likely you are to find it in particular places. However, that's not a guarantee. It would be the most efficient, not necessarily the most effective. The argument Newell and Simon would make is that there is an algorithmic solution. Systematically search every possible location for your keys, no matter how likely, and they would argue that while not efficient, it's more effective. It's guaranteed. Now, when it comes to processing information in order to try and solve a problem, they use the famous example of the Tower of Hanoi game, which I'll demonstrate for all of you in a moment. But they argue that all problems essentially exist of a few crucial theoretical conceptual elements. the first of which is an initial state. The conditions at the start of a problem, what it will look like at the beginning. In the example of the Tower of Hanoi example, it would look like that. All of the disks on the left peg by themselves. They would then argue that there is a problem space. All possible occurrences in solving a problem, so all of the possibilities that would exist in between the initial state and the eventual goal state would be considered as part of this problem space. They argue that all problems have parameters or operators, rules, essentially, things you can and cannot do in attempting to solve a problem. Now, in this particular instance, in the Tower of Hanoi, the operators of the problem would include the fact that you may not place a larger disk on a smaller disk, that you can only move a disk if it is not already covered by another disk, and that you may only move one disk at a time. Now, within those parameters, they argue that you'll conduct a means-end analysis, a strategy for trying to solve the problem, a way of coming to the goal state at the end. And of course, this would consist of many intermediate states, conditions between our initial and our goal state, which would look something like that. Now, there would of course also be sub-goals, intermediate states which would indicate progress. So as we can see, it's more of a non-insight or algorithmic process because we can progressively track how close we are to solution. And of course, finally, we would reach our goal state, the end state that we're hoping to achieve. Now, famously, Newell and Simon argue that, of course, there are many, many possible occurrences. There are many intermediate states within a very wide problem space, but the fastest solution they're aware of to this problem essentially consists of 7 moves. Now, I have a Tower of Hanoi sitting here and we'll demonstrate. We will move the first disk to the third peg, first intermediate state, second intermediate state, third intermediate state, fourth intermediate state, fifth intermediate state, sixth, and finally seventh. All of my sub-goals or intermediate states went from our initial state to our end state, as you can tell, through a means-end analysis, and I managed to maintain all of the operators without violating any of the rules of the problem. Now, while I've demonstrated that to you, I'm going to give you all kind of an unconventional thing, I suppose something you know I don't often do, which is that I'm going to tell you that I'll be asking you this in your exam. You have a problem that you will be required to solve using all of these concepts. Now, while of course I've told you all of what you need to know in order to be able to do this, and therefore you have no excuse not to be able to master that question, I will give you another hint as to what you're going to be doing, because I also would like you to consider the following challenge that you'll be confronted with in your exam. There is a possibility that you can actually solve this problem in less than 7 moves. I would like you to consider how you'll be able to do that. Now, in attempting to find a solution not only to the Tower of Hanoi problem but also to any problem, there are some tried and tested strategies that you might want to attempt to use. And again, moving back to sort of the running comparison I'm using with psychotherapy, one of the instances we find rather interesting in therapy is the fact that the therapist typically says nothing or very little, yet can be highly effective in that regard. So if we consider why therapy could be helpful even when a therapist says nothing throughout the session, what might be a reason for that? Well, firstly, according to problem-solving literature, there is in fact value in thinking out loud, what we call verbal mediation in neuropsychology. In some instances, we utilize a think aloud protocol, which forces us not necessarily to rely on assumptions, but to try and reframe the problem for ourselves because we're thinking like another person. This is particularly important because, of course, when you think to yourself, you're thinking in a sort of very casual, limited sense in the way that you would typically understand a problem. However, we often find something rather interesting. When we're forced to explain our chain of thought to somebody else, we automatically reframe and reflect in a manner that we wouldn't otherwise, because we're not thinking how we think about the problem. We're trying to think about the problem as somebody else might, and by virtue of doing that, take an objective stance to it. In so doing, we often notice certain errors in our thinking or our solutions, such as functional fixedness, that we are then able to overcome. A good example one often finds in cognitive behavioral therapy is by helping someone to identify their own underlying irrational beliefs. For example, the intense anxiety about an upcoming exam may have to do with a catastrophization. If I fail this exam, my career will be entirely over. Of course, they often find themselves saying, well, now that I hear myself say it, it actually sounds ridiculous. Because, of course, my career wouldn't be over if I failed this exam. At the very worst, it might be delayed, and I might have to deal with more protests, or in fact, I might find myself joining protests all of a sudden in hope of actually restoring something. Or, of course, it may have to do with the fact that, yes, it'll be inconvenient, but not necessarily the end of the world. And when that belief starts to shift, of course, we start to notice that the anxiety starts to dissipate somewhat. Still present, but much more manageable. The important thing about a think aloud protocol is that sometimes just having a listening ear, whether in therapy or otherwise, makes a big difference to us. At the same time, one of the most powerful tools we can have to solving a problem we find ourselves stuck in is taking a different road even though we go to the same destination. We use an analogy. This process of analogical transfer simply involves using the same structural process for a source problem, so the same basic idea, even though the surface features different. So maybe the details or the way it's dressed up is changed, but the idea behind solving the problem is identical. Dunker uses an excellent example of this in the radiation problem, which runs as follows. You are a doctor who is trying to assist a patient who you've diagnosed with a malignant tumor. The patient will die if the tumor is not treated. Now, the tumor is treatable using radiation. However, if you use a beam of radiation, it will destroy all healthy tissue before getting to the malignant tumor, which it would then destroy, which would kill the patient. However, if you use a weaker beam, it won't hurt the healthy tissue, but it also won't kill the tumor. How can you solve this problem? Now, not leaving you in suspense on this one, the solution in the problem is to use several weak beams of radiation which all converge onto the malignant tumor, therefore preserving the healthy tissue while destroying the tumor. Because the weak beams each don't hurt the healthy tissue, but all converge on the malignant tumor, they create the intensity needed to hurt the tumor. Now, once you understand the solution to that problem, problems which have a different surface features but the same structural process become easy. For example, consider the following fortress example. A king has a fortress, and a rival king wants to take over this fortress. The fortress has several different entrances, but each road is covered in mines, because apparently in this historical example, mines were invented during the Dark Ages, according to Dunker, but we'll leave that to be for the moment. These mines, when trod on by a heavy load, for example, many soldiers, would explode, killing the force. However, if it's only a few soldiers, the mines won't go off. The king requires his entire army in order to actually take over the fortress. How will he do so? Well, again, the answer becomes immediately obvious to us, because now he has to send small amounts of troops through each entrance in order to avoid the mines while also overtaking the fortress. Through the use of an analogy, things become very easy. An example that I like to draw upon, which sort of links back to this initial concern of therapy, is one of dealing with adolescence. I think it was 2 years ago that I had to work with a patient whose principal concern was an enmeshed relationship with a teenage daughter, which was causing severe conflict between the two of them. They were overly emotionally close, which was smothering her daughter's natural need for independence during adolescence. Now, this mother couldn't understand how her tendency to overtake decisions, to rule out possibilities, and to decide for her daughter was stymieing her development and causing problems. So we had to draw an analogy. I used the analogy of what happens when one cages a wild bird. Now, if you do happen to know how this works, or you ever have worked with wild birds, you'll immediately appreciate the fact that while a bird raised in a captivity has no problem with a cage, a bird that was once wild and has now been put into a cage struggles very much with such an adjustment. Wild birds, which have a natural sense of independence, tend to actually fight against being caged. Eventually, if left in a cage too long, they become more and more self-destructive and will even bludgeon themselves to death on the bars of the cage. The same occurs for adolescents. The more severe the limitations you place around an adolescent and the more insistent you are about what they can and cannot do, progressively the more self-destructive and outrageous they become. When using that analogy with this patient, it was the first time she seemed to comprehend what we were discussing. It truly made emotional sense to her. And she began to change her behavior accordingly. Simply by changing the surface features of the problem, we could help her better appreciate the structural process of what she was doing. She then came back with her own analogy, that she would no longer treat her daughter like a caged budgie. She would rather treat her like a hawk, a wild bird that is allowed to fly free and roam, but returns back to its owner where need be. This tended to resolve a lot of the issues between the two of them. Now, why this was valuable was not only the power of the analogy, but also because typically in such sessions, we find that the therapist speaks very little. Now, why is it that having said so little, one is capable of effecting big changes? Usually this has to do with expertise. Expert knowledge actually tends to be different from novice knowledge in a couple ways. Experts have more knowledge about their field than novices, to begin with. Experts also organize the information differently to novices in the sense that they have different categorization processes and heuristics, but also because experts tend to spend more time analyzing a problem than solving it. The skilled therapist spends the majority of the session listening and analyzing, even considering forms of analogy, before marshalling a solution, as often they tend to be more effective. Something to consider, I suppose, for all of us. Now, coming to the end of problem solving and how it works, I'd like us to think a little bit about perspective in terms of where problem solving is going. As you all know, I always like to end off with one of the emergent movements in neuroscience and cognitive psychology as a whole. And today's is a particularly interesting one. We often make the argument that two heads are better than one, unless, of course, we're struggling with collaborative fixation. But in the instance that someone adds value to our thinking, we often find that it is very helpful to draw on others as a source of support, advice, and guidance. We often solve problems as groups. Of course, this is the fundamental basis of all teaching, mentoring, coaching, and parenting. Given that that's the case, we often find that we like to assist others or be assisted by them, but Nicolelis et al. At Duke University have actually found that there might in fact be a way to make two heads connect in a very concrete, real way. Their research involves brain ablation studies in which they systematically damage particular regions of rat brains in the hope of actually determining what functions are localized in which regions. Recently, however, they took their research to a new level by not only damaging the regions of rats' brains, but then connecting wires that would actually link damaged parts and healthy parts of one rat's brain to an entirely healthy rat brain in another being. They actually plugged one rat's brain into another. Why was this important? Because when they damaged the parietal cortex of a rat's brain, they effectively made it incapable of navigating a maze because its visuospatial reasoning was impaired. When they took that damaged rat's brain and connected it to the parietal cortex of a healthy rat brain that was, of course, still alive, they found something remarkable. That rat was able to navigate the maze again. What they essentially did was put two heads together in a very real way. Could you for a second imagine the application of such technology in humans? Imagine you couldn't solve a mathematical problem, but as a result could plug into somebody's head and actually use their skills to do so. Imagine you wish to learn how to play the guitar, and you could plug your mind into that of Carlos Santana and master an instrument almost instantly. Imagine what we'd be capable of if we could actually connect to one another in a hardwired way. With technological advances, we may one day be able to borrow another's mind to solve problems in a very real way. Until then, however, we will be stuck with a lump of grey jelly between our ears for our own use and no other. I hope you guys will put it to good task as you're preparing for your exam. In the meantime, have a lovely week.